We are covering shear and moment diagrams for the FE Civil exam, a topic found in the Mechanics of Materials section of the NCEES FE Reference Handbook. The biggest trap on the exam is misinterpreting the sign convention. You must strictly follow the handbook's convention, even if it differs from what you learned in your university courses. Positive internal shear is defined as a force that acts downward on the right face of a cut section. Positive internal moment is defined as the moment that causes the beam to bend concave up, making it sag or hold water like a smile. A common exam problem will show a loaded beam and ask for the shear or moment at a specific point, or ask for the maximum moment. Getting the sign wrong leads directly to an incorrect answer choice that is almost always one of the options. For example, a simply supported beam with a single downward 10 kip load in the center will have end reactions of 5 kips each. If you make a cut just to the right of the left support, the internal shear is a positive 5 kips because the upward reaction on the left creates a downward force on the right face of the cut to maintain equilibrium. The moment increases linearly from 0 at the pin. The relationship between load, shear, and moment is critical and is expressed by two key differential equations you'll find in the handbook. dV by dx equals negative W and dm by dx equals V. This means the slope of the shear diagram is the negative of the distributed load intensity, and the slope of the moment diagram is the shear value. A huge exam trap is forgetting the negative sign in the load-shear relationship. An upward distributed load results in a positive slope on the shear diagram, while a downward distributed load, which is more common, creates a negative slope. The second equation tells us that the maximum moment occurs where the shear is 0. The exam will test this by asking for the maximum bending stress in a beam, which requires you to first find the location and magnitude of the maximum moment by finding where the shear diagram crosses the x-axis. Another common confusion point involves concentrated moments. A concentrated clockwise moment applied to a beam causes an instantaneous upward jump in the moment diagram. Many test takers instinctively think clockwise should cause a downward jump, which is incorrect by the established convention. For instance, if the moment diagram has a value of negative 20 kip feet just before a 50 kip foot clockwise concentrated moment, the value will immediately jump to positive 30 kip feet. To remember the moment convention, use this mnemonic. A positive moment makes the beam smile. This visual of a sagging beam helps lock in the idea of positive bending. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.